In the last class, we have studied about limitations of array and how these limitations are overcome with the help of the linked list, the definition of linked list, also the types of the linked list, and along with this, we have studied about the declaration of the linked list, how to declare the linked list. In this class, we are going to study some more topics. Again, I am repeating the types of linked list here. Various operations that are performed on the linked list and insertion in the singly linked list. So in singly linked list, the structure of node is something like this. You have a box and the box will contain two blocks. First is for the info part and the second is next part. So the declaration of this node will be done with the help of structure as I have told you previously. Struct node integer info struct node pointer next. So this is what the structure of the linked list of the node, and you can see that this linked list has four nodes, and each node containing the information and the address of the next node. The address of the second node is 4900, so this 4900 is allocated in the second block of the first node. So we can traverse from first node to the second node. Again, the data 15 is stored in this node number second, and the node address of the third node is stored in the node number second. So we can traverse from node second to node third. Again, we have 5 as the data and 3000 is the address of the fourth node. So we can traverse from third node to next fourth node. And if the node is the last node, you will store null in this. Finally, you will store null. This null indicates that this node number 20, is the last node of the linked list. So you can see with the help of the pointer, we can easily move into the forward direction. But we cannot move into backward direction. Why? Because we have only link to the next node. We have not linked to the previous node. So a different type of structure of node has been introduced to overcome this problem, and this structure contains the three parts of the node. Assume that middle part contains the info. It is not necessary that it is always middle, but for the graphical representation I am telling this part is the next part, address to the next part, and this part with the address to the previous part. So the structure of this node will be something like that. Struct node integer info struct node pointer next, and struct node pointer prev. Now info part is responsible for the data. This is the info part. The next part is responsible for next address, and the previous part is responsible for the address of the previous node. So the graphical structure you have written here like this, that you have three nodes and all the three nodes have allocated at 400, 600 and 800. Since this is the first node of the list, so previous to this node there is no node. So I have stored null here. The data is 1 and 6000 is the address of the second node. So here I have stored the 600 address. Again, in the case of the second node, that is the node number 5, its next node is 7 and previous node is 1. So 4000 and 8000 are allocated in next and previous part respectively. And the third node, its next part is null because after the third node there is no node. So its next part is null, but the previous part contains the address of the node number second, that is 600. So this is the doubly linked list. Now circular linked list, third type of node is the circular linked list. Circular linked list is the variation of singly linked list. It is variation of singly linked list. Now in singly linked list, at the last node of the list we store the null information. But here instead of storing the null, we are storing the address of the first node. So whenever we are traversing node by node and we are reaching to the last node, we can traverse from last node to first node also. This is the circular manner. So in the circular linked list, circular traversal of the list is possible. So there is an advantage that if we are at the last of the node, we can move to the first node in the list. This is called the circular linked list. And the last one is circular doubly linked list. In circular doubly linked list, it contains the property of both linked list, circular linked list as well as doubly linked list. So in this type of linked list, we can move in forward direction, we can move in the backward direction due to the property of doubly linked list. We can move in forward circular manner and in backward circular manner. All the things are possible here. We can move backward, we can move forward. Okay. So this is the most complex linked list. Now the operations, what operations we can calculate. First operation is create node. Obviously the node have two structures I have studied yet. First is structure for the singly linked list and second structure for the doubly linked list. So we can create either this node or this node as per our convenience. So creation of a node, new node is a operation. Insert a node in the linked list. For example, let's suppose we have a linked list like this. So three types of insertion are possible here. First, insert in front of linked list. We can insert the node here, and till now this node is the first node, but when we make this node the first node, we have to update some pointers. This node start pointing the first node of the list, and the start variable start pointing this node, and this pointing is cancelled. So this is called the insertion at the front of the list. We can also insert the node at the last of the list. And if this node is the last node, so we will cancel this, we will store null here, and the address of this node will be stored here, and it will start pointing this node. We can also store the node or insert the node at any specific position, that is position I. So these three types of insertion are possible in the linked list. Similarly, three types of deletions are possible as insertion. So deletion from the front, we can delete the node at the front, we can delete the node at the last, we can delete the node at a specific position. And the last one is traverse the list. Traversing of list means traversing all the nodes of the linked list is called the traversal. We'll traverse the linked list sequentially. Whereas in array, we can traverse the array randomly. Okay. Now here you can see that create node structure is given here. How to create a node? Since linked list uses the dynamic memory allocation concept, so malloc function is used for node creation. Now struct node is nothing but the declaration of the node, which contains two parts. First is the info and second is the pointer next part. Let's suppose info takes m1 bytes of memory and next take m2 bytes of memory. So this size of operator will calculate the size of this struct node, which has two parts. So it will calculate m1 plus m2 is the total size of a node, and this much memory will be allocated by struct node m1 plus m2. m1 is for the info part and m2 is for next part. And what the malloc function does, malloc function occupies this memory and it returns the starting address of this node. Let the starting address is 2000. So it will return, malloc function will return the address of a node. So the return type of this node, return type of this get node function will be nothing but address of a node. So address of a node is represented by a struct node pointer. That's why I have written struct node pointer get node return malloc size of struct node. Okay.